Good evening, ma'am. This is Nikhila from first year ECE section, and my roll number is 2340180481. My assignment topic is prove that gradient cross A cross B equals to gradient dot B into A minus gradient dot A into B plus B dot gradient into A minus A dot gradient into B. Introduction. In this presentation, we will prove the vector identity gradient cross A cross B is equals to gradient dot B into A minus gradient dot A into B plus B dot gradient into A minus A dot gradient into B. This identity is crucial in vector calculus and has applications in various fields such as electromagnetism and fluid dynamics. Understanding the cross product. The cross product of two vectors yields a vector that is perpendicular to the plane formed by the original vectors. The magnitude of the cross product is the area of the parallelogram formed by the original vectors. The direction of the cross product is determined by the right hand rule. Apply the vector identity. Start with the expression gradient cross A cross B. Expand the expression using the vector triple product identity A cross B cross C is equals to A dot C into B minus A dot B into C. This expansion simplifies the original expression in terms involving dot products and gradients. Expanding gradient cross A cross B. Gradient cross A cross B is equals to A into gradient dot B minus B into gradient dot A plus B dot gradient into A minus A dot gradient into B. Substituting the definitions of the dot product and gradient into the expanded expression. This step-by-step expansion reveals the components of the final result for the curl of the cross product. Final result. Gradient cross A cross B is equals to gradient dot B into A minus gradient dot A into B plus B dot gradient into A minus A dot gradient into B. The final expression shows the relation between the curl of the cross product and the dot product of the original vectors. This result is an essential identity in vector calculus and electromagnetic theory. Proof. Let A comma B be any two vectors. Consider gradient cross A cross B is equals to summation I into dou by dou x of A cross B. Summation I into dou A by dou x cross B plus A cross dou B by dou x. Summation I into dou A by dou x cross B bar plus summation I into A bar cross dou B by dou x. We know that A cross B cross C is equals to A bar dot C bar into B bar minus A bar dot B bar into C bar. Gradient cross A cross B is equals to summation I dot B bar dou A by dou x minus I into dou A by dou x into B bar plus I into dou B by dou x into A bar minus I into A bar into dou B bar by dou x. Summation I into I dot B bar dou A bar by dou x minus I bar into dou A bar by dou x into B bar plus summation I into dou B bar by dou x into A bar minus I into I dot A bar into dou B bar minus dou x. Summation B bar into B bar dot I into dou A by dou x minus summation I dot dou A bar by dou x into B bar plus summation I dot dou B bar by dou x into A bar minus summation A bar dot I bar into dou B bar minus dou x. B bar dot gradient into A bar minus divergent A bar into B bar plus divergent B bar into A bar minus A bar dot gradient into B bar. A bar dot A bar into divergent B bar minus B bar into divergent A bar plus B bar dot gradient into A bar minus A bar dot gradient into B bar equals to gradient dot b bar into a bar minus gradient dot a bar into b bar plus b bar dot gradient into a bar minus a bar dot gradient into b bar. Hence proved. Conclusion. In conclusion, the identity gradient cross a cross b is equals to gradient dot b bar into a bar minus gradient dot a bar into b bar plus b dot gradient into a bar minus a bar dot gradient into b bar is a fundamental result in vector calculus. Understanding this identity enhances our ability to analyze vector fields, solve physical problems, and derive important questions. By applying the principles of vector calculus, we can unlock the beauty and complexity of the mathematical relationship in the natural world. Thank you, ma'am.